Hey guys, welcome to my channel. I'm Coder. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today, we have an amazing problem for you guys, right? So let's quickly go ahead and read the problem statement, guys. So the problem's called find the town judge, right? So he says in a town, right, there are n people labeled from 1 to n, right? There's a rumor that one of these people, right, is secretly the town judge. If the town judge exists, right, then the town judge trusts nobody. Everybody trusts the town judge, right? And then there's exactly one person that satisfies properties 1 and 2. It's a good thing they telling us all those things, guys. You know, they pretty much tell us, what makes a person like to be considered a judge, right? So they give us the criteria that's gonna allow us to pretty much be able to know who's a judge or not, right? So it says given an array trust, right? Where trust of I and A sub I, B sub I represent that the person labeled A sub I trusts the person B sub I, right? Pretty much they're saying that for A and B, right? For two nodes, right? We're gonna be giving an array, right? A trusts B, right? Right? That's what they're saying right there, right? So that's kind of how they're saying it, right? It doesn't necessarily mean that B trusts A trusts B, but B doesn't necessarily trust A, right? Based on this alone, right? Yes, return the label of the town judge, right? If the town judge exists and can be identified, or return -1, right? So very, very interesting, guys. So this example that's give so pretty much what they're saying, guys. We're gonna be there's so they're gonna give us integer n, right? Pretty much tell us that it's like n people, right? Let's say there's like 5 or 3, right? And our job, right, is to find which one of those 5 people, 3 people, right, is the town judge, right? So that's kind of our goal, right? So we're trying to accomplish. So for the first problem, right, there's 2 people, 1 trusts 2, right? Because that's how we're reading it, right? So we could see that the judge for this example is 2, right? How they derive that? You can see that everybody trusts the town judge, right? Except the judge itself. It doesn't need to trust itself, right? All right, 1 trusts 2, right? Right. So the first criteria is met, right? The town judge trusts nobody. Now we know everybody trusts the town judge is met, right? The town judge trusts nobody, right? 2 doesn't trust anybody, right? Right? 1 trusts it, right? So those 2 criteria are met. So we could automatically say, guys, 2 is indeed the judge, right? For this example, 3. No, this second example, you can see that 1 trusts 3 and 2 trusts 3 as well, right? So everybody trusts 3, right? What I'm saying, there's 3 people, and there's 2 people that trust 3, right? And then 3 doesn't trust nobody, right? Right? So we could even say for everybody trust the town judge, right? Except the town judge itself, right? We can see that. We can say that if n-1 people trust a particular node, right? I mean, particular person, right? And that person doesn't trust anybody else, right? Then we could conclude that this person is the judge, guys. So we see 3, right? 3 people again, right? 1 trusts 3, 2 trusts 3, and 3 trusts 1. This doesn't make sense at all, guys, because none of them satisfies all of those properties, guys, right? You see 3 trusts 1, right? But 1 trusts 3. But it said that if a person is a judge, they cannot trust anybody. So it doesn't make sense, right? So none of them satisfy this criteria. So return -1, guys. So yeah, this is a very, very interesting problem. Very, very, kind of interactive, right? So how can we solve this problem, guys? What kind of logic do we need, guys? So we could see that this question kind of, can be easily modeled by, like, pretty much by using a graph, right? Pretty much the different vertices, the different, like, nodes in the graph, right, are pretty much going to represent the individual people, and then the edges are pretty much going to show the relationship between them, right? So the trust array, right, is pretty much going to help us in building that connection, right, between the different nodes and the graph, right? So this is I'm gonna be representing using a directed edge, guys. So a directed edge to signify that it's a one-way on a direction, right? Meaning that that A trusts B, right? Not B doesn't necessarily mean that it trusts A, right? Right? Because to show that relationship, this is easily telling us to be a directed edge, guys, right? On directed edge, right? So that's why we're using it like that, right? So we're gonna all the people on the graph, right? We're gonna have all those n people on the graph, and then we're gonna use the trust array that's given to us, right? That's gonna pretty much help us in drawing the connections between the nodes, right? In the graph, guys. So yeah, so let's go through a couple examples to see how we're gonna use after we have the graph. We're gonna do some kind of things to kind of help us in having the solution that we want, right? So once we build it, so I'm gonna give you guys a quick overview. So once we build a graph, right, what we're gonna do, guys, we're gonna pretty much after we build a graph, we're gonna pretty much check, right, if there's one node that satisfies those criteria, guys. So if we find that node, then we return that node as the judge, guy. If none of them fits this criteria, then we're gonna return -1, right? So let's go through a couple examples real quick, guys. All right. So let me put those down. So let me see. So like I said, guys, so for this one, right? So there's two people, right? So now we're gonna draw. There's one, right? And there's another node, right? That's just two nodes, right? Right. So now this array says that 1 trusts 2, right? So pretty much it's a directed edge, guys, right? So 1 trusts 2, right? So now, so the way that we're gonna one important thing that I also forgot to mention, right? So so the way that a node is gonna be considered judge, right, is so there's two concepts that you guys need to know, right? So the n degree, right? N degree pretty much means the amount of edges coming into a node, right? And then the out degree is the amount of edges coming out of a node, right? So make sure that we understand those two things that that I'm saying right now, right? Which is gonna be important because for what I'm about to say right now, right? So a judge, right? So pretty much, right, is gonna have, right, n-1 in degree for a, so pretty much the judge for that particular graph, right? So there's gonna be n-1 edges, right? n-1 edges. All right, its n degree is gonna be n-1, right? N degree, right? Its n degree is gonna be, right? Because there's gonna be n-1 people, right, that trust that particular person, right? That's how we derive that, because it says everybody trusts the judge except the town judge himself, right? So or herself, right? This is why we have that, guys, right? We have n-1, right? So there's gonna be n-1 trust 2, right? So there's like, no, that's good. Then the out degree, right? The amount of nodes that are edges that are coming out of a node, right? So, and also the out degree should be 0, guys, right? Out degree, right? Out degree should be 0, right? Which is important, right? Which is gonna be very, very important, guys. So it's 0, so the out degree is 0. What I'm saying, it needs to be 0 for it to be considered a judge, right? So in degree, there's n-1 people that trust it, and 0, and then out then there's it shouldn't trust anybody, right? That's why the out degree there shouldn't be any node edges coming out of that node, right? So you can see that 2 satisfied this criteria. Is n-1, it has an n-1 in degree, right? And then the out degree is 0, right? So that's how we end up with that, guys. So that 2 is indeed the result, right? So this one, it'll be interesting, right? So let's quickly draw real quick. 1, 2, 3, right? So now let's do the connection, right? So 1 trusts 3, right? So 1 trusts 3, right? So directed edge going from there. 2 trusts 3, right? And okay, 2 trusts 3, right? So we see that there's so the only node that has n-1 in degree, right, is 3, and then it also has a 0 out degree, right? So it satisfied those 2 important criteria, right? Everybody trusts the town judge, right? But the judge doesn't trust anybody, so that's why we return 3, guys. So let's go a little bit quicker. So this one's gonna be 1, 2, 3, right? So now 1 trusts 3, cool. 2 trusts 3, cool. But it says that 3 trusts. One makes no sense at all. So none of them fits that criteria, right? Even though it has an n degree of 2, right? You see that its out degree is 1, guys. So because of that, right, we don't have any node that satisfy those 2 criteria, guys, right? So because of that, we're gonna return -1, right, to signify that we didn't find that person, guys. So let's quickly go ahead and implement that in code, guys. So pretty much what we're gonna do, guys, we're gonna pretty much use the we need to represent the graph, right? So how are we going to represent the graph? So we know there's different ways to represent the graph, right? So agency list or agency matrix, right? So we're going to be using the agency matrix, guys. So I know there's a solution that we don't even need to even build a graph, guys. It's even more elegant. So if I have time at the end, I'll probably show you guys, the pretty clever way of doing it, right? So let's keep it consistent. So with everything that we've done so far, right? By representing the graph, and then doing and then checking the out degree and in degree of all of the different nodes, right? Just keeping it consistent, that as if like we've never seen this before, right? So now, guys, so map, right? So we're gonna represent the graph right now. So so a map, so integer triple integer list of integer, right? So it's called G, and then new. Okay, new hash map. I can't type today. I don't know why. Okay, so we got that. So what else are we gonna do now? We're gonna so yeah, we need to have the end degree of all the nodes, guys. So I did so we need to keep track of end degree, right? So pretty much she's gonna pretty much the label, right? You know what I'm saying? And then the count, right? This is what is gonna keep track of the end degree, right? Right, end degree, right? Hash map. All right. So yeah, since I'm using the adjacency list, right? So the out degree is going to be it's going to be we're going to keep track of the out degree with the list, right, that belongs to a particular node, right? So if you don't know what I'm talking about, I have a playlist on graph, so go through that playlist so you can kind of understand how and why we're doing that, right? So pretty much this is gonna hold all the nodes that node is pointing to. So we can easily check, all right, cool, what's the out degree, right? Oh yeah, if there's 2 nodes in the list, then we know that the out degree is 2, right? It's pointing to 2 nodes, right? That's how why it's so good for us, right? So pretty much this is gonna help us in the initialization step. All right, so it's labeled from 1 to n, right? So very, very important, right? Labeled from 1 to n, guys. So that's why I'm doing this, right? From 1 to n. ++. You have put I, and then new array list, right? All right, so okay, so now we have that. What's gonna be the next step, guys? What's the next step that we could do? So add okay, T and trust, right? So now let's get the data out of there, right? So T is 0, right? For every vertex edge, right? Connects U and V. That's what we're gonna do. So let's do G that gets U, right? And then add V to it, right? So that's what we're pointing to. And the end degree, right? That put with V, right? Because the end degree of that node gets incremented by 1 because now it has one more node, right? That's pointing to it, guys. This is where I'm doing this, right? Make sure that you guys understand what I'm doing right there, right? And then if V 0 + 1, right? Yeah, so after we do that, we're already in good shape. And the next thing that's left for us to do now is so we've populated everything here, right? So now we're gonna loop through what's it called, the G that key set, right? So we're gonna loop through all the nodes, right? Okay, so if that n degree, right? We have n degree that gets node, right? So if the n degree of that node, right? So the amount of edges coming into a node, right? So if that n degree equals to n minus 1, right? Right? So if there's that criteria, and g that gets node, right? That size, right? The size of the list, right, is equal to 0. Then we found our judge, guys, right? That's our judge, right? If we never find it, right, we're gonna simply return a -1 to signify that, right? Let's see if we're in good shape. It seems like we're good though. Let me see. I forgot one thing that report. I'm tripping. Yeah, make sure that right there, guys. Very important. I meant to put I. All right, seems like we're in good shape, guys. Let's quickly check. Let's press submit. Perfect, guys. It seems like we passed all the test cases, guys. So, yeah, this is a very good problem, guys. Hopefully you guys learned a lot. If you guys, really like this solution, make sure you give me a like. I would really appreciate that a lot. If you guys are new here, subscribe to the channel because I'll be doing a lot of other videos just like this one, guys. So, I want to thank you guys for watching, and I'll see you guys in the next one.